Hello, let's get started. So, I forgot to share my screen. First thing that we're going to do is flip the paper over. So you should have day 11, factoring when a is equal to 0. And the first thing that we're going to do is flip the paper over where it says the list of perfect squares. So I'm just going to show you how to get started, and then you are going to do the rest. Okay. So the list of perfect squares. So it's got this column is for x's and this column is for x squared. Okay, so if x is 1, then over here we're going to do 1 squared. Or 1 times 1, which is just 1. Next is going to be 2 squared, and then 3 squared, and so on. So 2 squared is the same as 2 times 2, which is 4. 3 times 3 is 9. You don't have to write this column, and you can use a calculator to help you. You do have to write this column. So this box is going to be 4 times 4, which is 16. And then we have 5 times 5, 25. 6 times 6, 36. So you're going to create this chart for perfect squares. Pause the video, make your chart. Pause the video and make your chart. Okay, now we're going to flip over the paper and we're going to start with factoring a difference of perfect squares. That's what goes in the blank. So the big thing with these types of problems, they're always only 2 terms. But a difference means subtract. So they have to be 2 terms subtracted. So you can jot that down. Must be subtraction. Okay, that's a big one. Also, we want to always check for a GCF. GCF stands for the greatest common factor, and I'm going to show you how to work those problems down at the bottom of the page. Next, they have to be perfect squares. So it has to be something squared minus something squared. And so they have to be in this format where you've got a squared minus b squared, whatever a and b are. And then we're going to use this formula. And so it turns into a minus b times a plus b. And that is the same exact thing as a plus b and a minus b. So it doesn't matter if you have the minus and then the plus, or the plus and then the minus. You just need to have a and b in that order in both sets of parentheses. One has to be a plus, one has to be a minus. It doesn't matter which one. Let's do a problem. So the first problem, and I want to see this step on everybody's paper. Do not go to the answer. You will not get full credit on your homework. So what I need to see is that you rewrite this as something squared. That one's already something squared, minus something squared. So 4 is not written as something squared, but you can use this chart on the back. So when you see, well, actually, it might be helpful to have all of these written out. I just thought of that. So like here, if you have the number 4, it's something squared. So over here, 4 is 2 squared. So we're going to rewrite it as 2 squared, or you could just come over here and know that it had to be 2 squared. But it might be helpful to go ahead and jot down on your perfect square list that this was 4 squared and 5 squared and 6 squared. So for some of you, it might be helpful to see that. Oh, I should have an equal sign. Okay. So I'm going to rewrite 4 as 2 squared. So this turns into x squared minus 2 squared. And as soon as you have it written as something squared minus something squared, it's going to use that formula. So I'm going to have parentheses And I write the first thing first. X is first, so it's going to be first in both sets of parentheses. The 2 is second, so it will be second in both sets of parentheses. And all I have to do is put a plus and a minus in each set, and it doesn't matter which one, but one's got to be plus, one's got to be minus. And that is your answer. That's it. Again, I want to see this step right here. Next problem. I need to write it as something squared minus something squared. Well, hey, we already know what 4 is. 4 is the same thing as 2 squared. And this is going to look very similar to this problem, but the position is different. So I still have to do this step. This is 2 squared minus x squared. And I'm going to use the formula. First things first. So the 2 is first, so the 2 gets written first this time. X is second, so X gets written second this time. And one of these has to be plus, one of them has to be minus. It doesn't really matter which one. So I'm going to put minus first this time, and then a plus. So these are not actually the same answer, and you can tell because of the position. And so yes, X plus 2 is the same thing as 2 plus X. That's the same. But X minus 2 is not the same thing as 2 minus X. Position matters for subtraction. So next, X squared minus 9. So again, you can use your chart. You can come over here. 9. 9 is the same thing as 3 squared. And so I'm going to use a rewrite as X squared minus 3 squared. And I'm going to use my formula. First things first, X is first, so X goes first. 3 is second, so 3 goes second. 1 has to be plus, 1 has to be minus. It doesn't matter which one. And I'm done. So that is a difference of perfect squares. So you can go and you can look at your homework, difference of perfect squares. In fact, if you want to pause the video and go do the problems for difference of perfect squares, you can do questions 4 through 9. Moving on. Next, we're going to learn how to factor trinomials when a is equal to 1. And so trinomials, tri means 3. So there's 3 terms. And we have a, b, and c. So when a, which is the first number, is equal to 1. So if you look at all 3 of these, what you'll notice in common is that the number in front, and we know that when the number isn't written, it's a 1. So I have a 1 in front. And the way that we solve these is the same. First, we want to check for a GCF. We're actually going to do that at the bottom of the page. Next, it says that we need to list factors of a times c. So I'm going to label my terms. This is a, b, and c. A is always the first number. So when the leading term or the first number or the a value is 1, you can solve problems like this. And the first thing that you do is a times c. And so when I do a times c, what's anything times 1? Itself. So I am multiplying 1 times 36, I get 36. So this is side work, and yes, I want to see side work. I'm going to see everybody showing this step. So off to the side, I'm going to have factors of 36. This is when I can tell that you looked up the answers, because the answers aren't going to have this step. So off to the side, factors of 36, I start at 1. 1 times 36. 2 times 18. 3 times 12. 4 times 9. 5 doesn't go into 36. 6 times 6. And then you don't have to repeat them, because next you would have 9 times 4. Well, you already have that right here, so you don't have to list it both ways. So I just start with 1 and I see, like, does 1 times something equal 36? And you use a calculator. Use a calculator if you're struggling. Oh, also, one way that you can find factors, on the calculator, you can type in y equals whatever the number is. So this is 36 divided by x, and the x button is right next to the alpha key. And so if I spoke too fast, pause the video, rewind it, and then read this again. So it should look like this, where I've got 36 divided by x. And then if I press second and then table, or second and graph takes you to the table, and then I see a list. So this list starts with 0, and 0 is an error because you can't divide by 0. But next you see the same factor list just like I created. 1 times 36, 2 times 18, 3 times 12, and so on. And so we want to write down the whole numbers. So use your calculator to help you find these values. Once I find all the factors, next I'm going to get my problem set up. So it says that the next thing I'm going to do is I'm going to get this set up, and I'm going to figure out the factor pair. These are my factor pairs that can be put together to make B. So I'm going to show you what that's going to look like. It's kind of both those steps in one. So I'm going to get factors. It says that it's going to be factors, and there's going to be an X and an X. There's an X and an X because it's what two things can multiply to give you X squared. X times X gives you X squared. So you're always going to start out with X and X. Next, I'm going to look at my factor pair, and I'm going to see which pair could either add or subtract. That's why I say put together. Which pair could put together to make 13. So what I notice is that 4 and 9 can put together to make 13. 9, 10, 11, 12, 13. 9 and 4 can put together to make 13. So I'm going to circle my factor pair. And it doesn't really matter what order that this is in, but the way that I make my factor tree, or my list of factors, I tend to have the smaller number on the left. It doesn't have to be, but that's how I create it. So I'm going to put in my parentheses the 4 and the 9. 4 is going to go here, 9 is going to go here, but it doesn't matter if you switch the order. It doesn't matter. 4 and 9. Next, I have to figure out what signs go in here, because I have to have a plus and minus, plus or minus here, plus or minus here. So to figure it out, I always look at my middle term. So this is this. B determines the sign of the bigger number. So 13 is positive. So the bigger number is 9. It tells me that the 9 is going to be positive. From there, I figure out the other one. If I have 9, would I add or subtract to make 13? I would add. So my other term is going to be a plus. And there you have it. You're done. And 36 has a lot of factors. Not every number has a lot of factors. Let's do it again. So I'm just going down the steps. Check for a GCF. So that's just looking for, is there any number that can divide into all these? And the answer is no, because the leading term is 1. So now I do A times C, 1 times 15, and 1 times 15 gives me 15. So I'm going to make a list of factors for 15. You can use your calculator. So those steps again, you go to y equals, and you're going to type in 15 divided by x. And then you're going to go to the table. So you press second, and then graph will take you to the table, and then you have a list of factors. The factors of 15 are pretty small. So I start with 1. 1 times 15. 2 doesn't go into 15 evenly. 3 times 5. I've got a pretty short list. So now I am ready to get my problem started. I'm always going to start out with x and x. And now which factor pair can I put together to make 8? Can 1 and 15 make 8? Because 15 minus 1 is 14. 15 plus 1 is 16. And I could do a variety. 1 plus 15, 1 minus 15. It doesn't put together to make me 8. What about 5 and 3? Yes, it will work. So I'm going to take 5 and 3. I'm going to put those in parentheses. Again, it doesn't really matter if you put the 5 here and the 3 here. It doesn't matter. I got to determine Which number is bigger? The 5 is bigger. So 5 is going to have the same sign as the B term, the middle term. The middle term is going to have the same sign as the bigger number. My bigger number is 5, so it will be positive. 5. If I have 5, would I add or subtract 3 to make 8? Yes, I would add 3 to make 8. And I am done. The more problems you do, one thing that you'll notice is that anytime that these are both positive, these are both positive. So we just did that on both of these problems. If there's not a negative in your problem, you're not going to have a negative in your answer. So when it's all positive, this is all positive. My next problem, I have negatives, so I'm going to have negatives in my answer. So I really have to go through which term is bigger, and then I have to figure out the signs. So this problem number 6 will be a little different. Same first step. I would check for a GCF, but I know that there isn't one because the leading term is 1, and the only thing divisible by 1 is 1. No GCF. We're going to talk about that in a minute. So then I do A times C, 1 times 13, and I ignore the negative for right now. 1 times 13 is 13. And then I get a factor list of 13. This is an even smaller list. You could use your calculator. Y equals 13 divided by X. And then second, and then table, our second graph will take you to the table. I only have one factor for 13, one factor pair. 1 times 13 gives you 13. That's it. So I already know what's going to go into my parentheses. I'm going to start with an X, and then I'll have a 1 and a 13. So my signs, my B term is negative. So that means the bigger number is going to be negative. From here, if I have negative 13, would I add or subtract 1 to make negative 12? And you can always use your calculator to help you. If I have negative 13, I would have to add 1, because if I subtract 1, I would have negative 14. So I'm going to add 1. And that's my answer. So you can always check your work by making sure that this number times this number, they have to multiply to give you the last number. And then they have to add or combine, I would rather say combine, to make the middle term. So 4 times 9 is 36, and 4 plus 9 gives you 13. 3 times 5 gives you 15, and 3 plus 5 gives you 8. So it's what will multiply to give you the last term that'll add to give you the middle term. Last, 1 times negative 13 is negative 13. 1 minus 13 is negative 12. Now you can do questions 13 through 20 on the back. Make sure that you show me this step right here. And I want to see things like this arrow, that you're being mindful for the sign. Okay, again, this is how I can tell who cheated and looked up answers and who actually did it. So please make sure you show me all the work. We only have a couple more problems, and then we're actually done with this video. So next, we're going to talk about the GCF, or the greatest common factor. So the greatest common factor is the biggest number that can divide into both terms. So for this first problem, and this first problem is very similar to on the homework questions 1 through 3. So for this problem, the biggest number that can divide into 5 is 5. The biggest number that can divide into 45 is 45. So what's the biggest number that could divide into both of them? Well, the biggest number that can go into 5 and 45 is going to be 5. So I can divide out of 5. Now I'm going to start looking at the x's. So what's the most amount I can pull out of both of them? So I could pull 2x's out of this one, x squared, but this one only has 1. So the most amount that I could pull out of both is going to be just an x. Anytime you divide out of greatest common factor, it has to be written out in front. You don't lose it. It doesn't go anywhere. So my problem starts out with 5x, and then in parentheses, I'm going to write down what I have left after I divide it. 5 divided by 5 gives me 1. Next, if I have x squared on top and then x on the bottom, what's technically happening is that I have 2 x's on top and 1 x on bottom. Anytime you have x's that can match up, they cancel or they turn into 1. So what I'm left with is just 1 x on top. So over here, I just have an x. I don't change the sign because I'm not dividing out a negative. 45 divided by 5 is 9. 9. And then x divided by x is just 1. So I don't write anything there because I pulled out that x. I'm dividing it out. If you wanted to check your work, you could distribute this back in. 5 times 5 is 5. X times x is x squared. So you'd get 5x squared, which is what you started with. 5 times 9 is 45, and there's an x attached to it. That is your answer. So it's the backwards, it's going backwards from distributing. So the greatest common factor is the opposite of distributing. And I can't factor any further because this doesn't factor. Next problem. So I'm going to do the same thing. What can divide into both 2 and 50? They're both divisible by 2, so I can pull out a 2. They don't both have an x, so I can't pull an x out this time. So out into the front is going to come a 2. And then I'm left with x squared minus 25. Can I factor this any further? And I'm talking about the stuff in parentheses. Can I factor this? Yes, 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 yes. It's a difference of perfect squares. And so 25, I'm remembering, is on my perfect square sheet. And so this is the same thing as 5 squared. So I'm going to rewrite this 2 and then x squared minus 5 squared. And now it's a difference of perfect squares. I have it all set up, a squared minus b squared. And so I know that that formula looks like this. First things first, x and x, 5 and 5. And then difference of perfect squares. The formula says one has to be positive and one has to be negative. Doesn't really matter which one. And now I can't factor any further. I am all done. And factoring is the opposite of multiplying. So I can multiply all this out and I would end up with what I started with. And my last problem. So now you can go do question 1. This is like question 1 through 3. This one is like questions 10 through 12. Oh, it looks like my directions for the back is at the bottom of the front page. That's okay. Question 9 is going to be like question 21 and 22. So I noticed that this is not a equals 1. And so the first thing that I want to check for is a GCF. Are they all divisible by 2? Is 14 divisible by 2? Is 24 divisible by 2? Okay, so let's factor out a 2. And they don't all have an x. This one's missing an x, so I can't pull out an x. So all I can do is factor out a 2. Anytime you factor something out, it gets rewritten out into the front. 2, and I'm left with 2 divided by 2 is 1. So I get 1x. 14, 1x squared. 14 divided by 2 is 7. And there's an x. 24 divided by 2 is 12. Now, this is just like the problems that I did where I've got a is equal to 1. And I'm going to make a factor list. 1 times 12 is 12. Factors of 12. 1 times 12, 2 times 6, 3 times 4. Now I'm ready to set up my factors, and I have to come up with factors. Oh, I missed. Okay, so now I have to come up with factors of 12 that can be put together or combined to make 7. So which factor pair can I put together to make 7? And this is one of those situations where these are both positive, so they're both going to be positive. And I will start out with x and x. Yes, 3 and 4 can put together to make 7. But again, you can also go through the process. The middle term is positive, so the bigger number will always be positive. If I have 4, would I add or subtract to make 7? I would add. Beautiful. We are done for today. You can go and work questions 22, 21, and 22 now. Please be productive with your time.